Hello geometry students, welcome to the Chapter 8 review. Here you'll see me go through each and every problem from the Chapter 8 review. You can just rewind to the ones you need, fast forward to the ones you need. You don't have to watch the whole thing. This is just for you as an extra tool, extra resource to help you in your preparation for the Chapter 8 test. So let's check out 1 through 4 here. I'll do that. Why don't I split this up into 4 relatively equal parts here. I think that should be enough space to solve each one of these. So this is algebra type review. Let's work these out. So 3 over x and then 2 over 7. You can cross multiply. You're going to get 2x equals 21. Divide by 2. Both sides you're ending up, the 2 will cancel. You get x is 21 over 2. That's an acceptable way to put it. 2 goes into 21 10 whole times with 1 left over. So you could write it like that, and you could also write it as 10.5. It kind of depends on the situation which is best of those, but those are 3 possible ways to write the answer to that one. For number 2, we'll rewrite what we have there. A plus 1 over 5 equals 2a over 9. Again, cross multiply proportions, you can always do that. Think of parentheses being around here though, so think of that as 9 times a plus 1. Always think of invisible parentheses around your parts of the fractions, and the ones you need to write in, or at least need to think about writing in for the next step, definitely put parentheses around those. I think that's going to be helpful for you. Here we have 5 times 2a, which is 10a. You can distribute the 9, get 9a plus 9 equals 10a. And if I subtracted 9a from both sides, that will give me an a, positive a on this side. It will give me a 9 on that side. So that's an a, already a little curly q there to make that a little clearer. And so for that one, a equals 9. For number 3, got 2 over x plus 1 equals 4 over x plus 6. Again, cross multiply. Think of there being parentheses here and here before you do that. So you're going to have 4 times x plus 1 equals 2 times x plus 6. Distribute the 4 here, distribute the 2 here. You have 4x plus 4 equals 2x plus 12. Now here you can subtract 2x from both sides. That gets your x's on the left side. This will cancel out here and here. And so I want to move my regular numbers to the other side. I can subtract 4 to do that. That's the easiest way, I think, to do this one. And finally there, divide by 2. You've got your answer, x equals 4. And number 4, got d minus 4 over d equals 3 over 7. Cross multiply once again. Parentheses here, 7 times d minus 4 is on one side, 3d is on the other side. Hot 3d, very nice. Okay, and 7d minus 28 equals 3d. This one, it looks like it'll save me a step if I do that, and rather than add 28 and subtract 3d. That's another possibility, but I'm going to do that this way and divide by negative 4 now instead. Negative divided by a negative will make positive 7 equals d. So those all check out. Let's move on to the next couple of examples here, a couple of problems. Number 5, by a 13-inch scale model of the sculpture The Dancer by Edgar Degas. The ratio of the height of the scale model to the height of the sculpture is 1 to 3, so it's apparently 3 times smaller is another way to think of that. So find the height of the sculpture. We can set up the ratio. We can say the height of the sculpture is equal to, we'll just call it x. And so the scale model, 13-inch scale model, we're going to make that same comparison. We'll compare scale to real. We'll keep that comparison going all the way across in our proportion. We can set up this proportion. We know it's 1 to 3 is the scale to the height of the actual sculpture would be 13 to x. That has to hold if that's going to work out like that. So we have x equals, very simply, 39. 39 what? Inches. Nothing else to do here because it's just plain old x. So 39 inches. And then number 6, the ratio of the birth weight to So the adult weight of a male black bear. Wow, that is crazy. 3 to 1,000. 3 to 1,000. So we'll make that comparison. Keep the birth weight on the top and keep the adult weight on the bottom. You could flip-flop those, but then you'd have to keep the adult weight on the top and the birth weight on the bottom the whole way through. And so let's see what we have here. We've got 3 over 1,000. That's a legitimate comparison. Birth weight to adult weight. That's the ratio they give us. It says the birth weight is 12 ounces. So I could put 12 here. And the adult weight, I don't know. I'm going to call that X. So average adult weight, I'm going to say that's equal to X. Let's figure out what that is. This ends up being 3X is 12,000. And you divide both parts by 3 there. That means X equals 4,000. Now there isn't a black bear that I know of that weighs 4,000 pounds. This is in what? This is in the birth weight's in ounces. That means this is also in ounces. But we're supposed to find the adult weight in pounds. So what do we need to do with that number? We need to know how many ounces there are in a pound. That number is 12. So there's 4,000 ounces divided by 12. And if you take a calculator out, let's do that quick here. If we have 4,000 divided by 12, we end up getting what is not the right answer. Let me double check something a second here. That's what I'm doing. Why am I putting 12 here? I don't know. That's 16. There's 16. Hopefully you caught that mistake. You're yelling at me, Mr. Wagner. I'm yelling at you through YouTube. Why are you doing this? I don't know. Because it's been a long day. How about that? Okay, so 4,000 divided by 16. There we go. 250 lbs for pounds. You can write that. So we have this divided by 16. Why are we dividing by 16? Because 16 ounces equals 1 pound. That's why we can do that. All right, let's move on to 7, 8, and 9. We're using parallelograms D, E, F, G. And we're saying that they are similar. So this is, remember, you read it is similar to H, J, K, L. So that implies two things, that all angles are congruent and that all sides are proportional. Two major things to remember for similar shapes. So find the scale factor of these. So I would look here and I would find something that matches up. I know since this is a parallelogram that this has to be congruent to this. So this also has to be 30. I know these two are also congruent, but I see that this is 30 and that this is 30. EF, that's the second two letters here and here, matches up with JK, the second two letters here, the middle two letters, probably a better way to say that. EF matches up with JK, and so 30 over 18 would be my scale factor from this one to this one. So notice I'm going from here over to this one. So bigger to smaller. Number 7, the scale factor, you're going to have 30 over 18. You can reduce that. You can divide both parts by 6, and you'll have 5 over 3. You can write it like that, or you can write it like this. I would take either one of those as acceptable answers. Number 8, find the length of DE and the measure of angle F. So what's the length of DE? We know that this one's 27, and we know, I'll do this in green here, this one's 27, and this one we don't know. I'll call DE, well, I'm going to call that, I'm just going to call it DE. I'm just going to leave it as DE. So this is DE. I know if this is 27 though, this also has to be 27. And I know that this one matches up with this one. This is DE right here. So how can I set this up? I'll do this in green just so you make the connection here that I'm doing number 8. This one, I'll circle that in red. So I did that stuff in red, 30 over 18. And then the green part matches up with the green stuff up here. So I can say that 27 compared to DE, or DE compared to 27, that's probably the easier way to think about this one. Because I have that scale factor already. I've got 5 over 3. So I can use this and say that 5 to 3, this side, or anything here compared to anything here, is in that 5 to 3 ratio. So that DE over 27 must equal 5 over 3. DE is going to be bigger than 27 in that 5 to 3 ratio. So here, cross multiply, work it out from there, and you're going to get, let's see, 5 times 27, that would be 135. 3 times DE, you could just leave as that, right? It's 3 times DE. If you divide 135, divide that by 3, you end up getting 45. So 45 is the length of DE. We would write that without the segment mark above it if we're saying it's the length of that segment. So DE would equal 45. And then number 9, the ratio of the perimeters. I'm not done though with number 8. Sorry, the measure of F. Getting ahead of myself there. The measure of F is going to be, here's 67 here. These are similar, so that must match up. That's got to be 67. So what's left over here? Remember, these are supposed to add to 180 degrees. So what would you have left for the measure of angle F? Measure of angle F would have to equal 113. Because, why is that? If I asked you why that was, you would just tell me it's 180 minus 67. Now I can move on to number 9. So number 9, find the ratio of the perimeter to the ratio of the perimeter here. This one, be careful, it's saying from this one to this one, from now the smaller one to the bigger one. So theorem 8.1, it says that the ratio of the perimeter is the same as the ratio of the sides. So if we think about that, the ratio of the perimeter is equal to the ratio of the sides. So the ratio of sides from HJKL to DEFG, that would be, instead of 5 over 3, that would be 3 over 5. So that means by theorem 8.1 that the ratio of the perimeter is the same thing. The ratio, I'll write that down, the ratio of the perimeter is also 3 to 5. We don't actually need to calculate the perimeters. We can just assume that it's the same as the ratio of the sides. All right, moving on then to number 10 and number 11. Number 10, determine whether the triangles can be proved similar or not, and number 12. 10, 11, and 12 here. Explain why or why not. If they are similar, write a similarity statement. So this is 104, this is 48, this is 104 and 28. We need at least 2 angles matching up to be able to use angle. That's what it looks like we could use here. That's what it looks like we might be able to use here. And it also looks like what we might be able to use here. So let's see, number 10. What's missing right here? This would be 180 minus those two added together, minus 104 plus 48. That's 152, which would make that 28. So this is 28 degrees, and so is this. That's 28, that's 28. You could also figure this one out. This would be 48. So you can say yes by angle. But you would need to show me some work with that one. So you needed to show me something like that. Either draw the picture or say that the measure of angle S equals this. And you show me that 28, 28, those are the same by angle. So what's a similarity statement? We're supposed to write that for each one. How do these triangles match up? We could say triangle SUT would be one way to write it. S to U to T would match up with V to X to W. There's other orders to write the letters in, but they have to correspond with each other. S has to match up with V, U with X, and T with W. Whatever order you write them in, they have to match up in that way. For number 11, let's see what we got here. This is 75. This is 38. What's left over? If it's 64, then I've got angle. If it's not, then I don't. And so let's see. We've got 180 minus 38 plus 75. That would be 38 plus 75 would be 113. And then 113 subtracted from 180 would be 67 degrees. So on this one, it looks like this is this is 67 degrees right here. And this is 64. This one you could figure out as, this would be 64 plus, let's just do the math on that one here, plus 75, that's 119. And 119 subtracted from there, that'd be 61 degrees right there. And so 61 goes right there, 67 goes right there. These are clearly not going to match up. There is no angle part to this. So I would say you showed the work right here, something like that. That is sufficient to prove that they're not similar. All angles have to match up. If they are similar, they clearly do not. Here you've got this angle matching up with this angle, and you've got no other information here, or so it might seem at first glance. But remember, vertical angles, this one has to be congruent to that one. And so you just need two. That's all you need. So this one is a yes by angle, and I would say something about vertical angles are congruent. So that's why angle works in that one. And what's the similarity statement? You could say this is n to q to p. Let's start in that order. You could start in a different order, but the letters matching up with n, whatever the first one matching up with n is over here, that's how you have to have it matching up. And so n matches up with r. So wherever you write n, if it's first, r needs to be first. If it's second, r needs to be second. If it's third, r needs to be third. And then q matches up with q. So r to q, n to q, same thing. One angle congruent, two angle marks congruent, and then p would match up with s. Let's move on then to number 13. Number 13 and number 14, same directions, they go together. Are the triangles similar? If so, state the similarity and the postulate or theorem that can be used to prove that they are. So to check this one, remember you have to have all angles congruent, all sides proportional. So sides being proportional, let's check that out if we have that here. And so how can we check that? We can check, compare biggest side to biggest side, and then middle side to middle side, smallest to smallest. I'll color code things here to make it easier to see. So 27 is the biggest, 42 is the biggest over here. The next in line would be 26, 39, and finally you'd want to check 14 and 21. So let's check those fractions and see what we get. 27 over 42, you can reduce, you can divide by 3 and get 9 over 14. So that's as simple as that can get. That's as simplified as that can get. Here you've got 26 over 39 for the middle parts. You can divide by 13. Both of these, you can get 2 over 3. Now this and this, these are not the same. Clearly, then it's not going to be similar because they all have to be proportional. They all have to be the same units. I'll just do the blue one just to get the extra practice. You can reduce, divide by 7. And so 2 of them are the same, but all 3 have to be the same for them to be similar, for the triangles to be similar. So we say they're not all the same. So can you prove that they're similar? I would say so no. So show me some work for that. Don't just say no, but show me how you got that. And then over here, it looks like we do have that side angle side similarity postulate, and we also have side similarity postulate. So that's what I was trying to use here. I was trying to use side similarity. If all the sides were proportional, then yes, they would be. It didn't work out. Here I'm only given 2 sides, and I don't have any angles at first glance, but remember, vertical angles, this one is congruent to this one. So it's possible that side angle side similarity will work here. I just need to check the proportions and make sure that they are proportional, that the ratios stay the same. So this one matches up with this one, 37.5 compared to 30. 25 matches up with 20. And so with 14, you can check those, see what you got. So with a decimal, you can move this over 1. You can move the decimal here over 1. You're going to fill in a 0. So that's saying the same thing as 375 over 300. 25 goes into both of those. This goes into there 15 times. It's like quarters. Think of how many quarters goes into $3.75. This would be 12. I could reduce that one more time and get 5 over 4. So that is that one fully reduced. And then in green, I've got 25 over 20. I'm going bigger to smaller here, just like I did here, bigger to smaller there. 25 over 20 can be reduced to 5 over 4. So these are the same. These are the same. And so we can say, so by side, angle side similarity, not congruence, but similarity, we can say yes, they are similar. Sweet. All right, let's move on to number 15, 16, and 17 all going together. So we had these theorems that related parallel lines like this. There's different ways you can write valid comparisons. I'm going to try to use what I think is the easiest way for each one. So for number 15, we can compare 11 to x. Because these are parallel, we can use that theorem that we had. We compare 11 to x. I don't remember the number of the theorem. Let me look that up a second. So for those of you interested, going back and seeing what those were, this is theorem 8.4. This one's going to use theorem 8.6. And this one's going to use theorem 8.7. So if you find that helpful, just a little extra piece of information there for you. 11 over x would be related in the same way as 12 is to 24. So 12 over 24. You might notice that, yeah, that's 1/2 here. So whatever this is has to be 2 times bigger. Yeah, that's okay to do that. You could reduce first. So why don't I do that here? I could say this is 1 over 2. Makes the math a lot easier to do. You're going to have 11 times 2, 22, equals x times 1 equals x. So x equals 22 when you do that. Theorem 8.6, I can say that this over this, that y, or 7 over y, it doesn't really matter if I do y over 7 instead of 7 over y, as long as I compare this one in the same manner. So y compared to 7 is the same thing as 15 compared to 10, based on theorem 8.6. So 15 over 10. Let's reduce first, might as well. This would be a 3 and a 2, cross multiply. Excuse me. And you end up with 2y equals 3 times 7, 21, divide by 2. That cancels, you're left with y equals 21 over 2. You could write that as 10.5. You could also write that as 10.5. Any one of those would be acceptable. My pen stopped working there for a moment. There we go. And there it is. And then 17, how this is related. This one's going to be a little trickier here. We can still set up a proportion. So if we're going to go strictly with the way the theorem is, you can think of this as h. This then would be 40 minus h, this part. And so if we're going to stick with the way the theorem aligns it, it would look like this. I'll tell you another way that would work though after I do this. So h is to 40 minus h as 24 is to 35. The h and the 24 go together just as the 40 minus h and the 35 go together. So this would be that over that. I could also have compared h over 24. So this compared to this would be the same as this part compared to this part. That's another valid comparison. So I could say h over 24 would be 40 minus h over 35. That would just flip-flop these two, but when I cross multiply, it doesn't make a difference if the 24 is here or if the 24 is here. After I cross multiply, I'm going to be multiplying them together anyway. So we'd have 40 minus h like that. Don't forget to think of that being in parentheses. This is 35h. Distribute the 24. Ooh, that's a more challenging one. I think it's at 960. I think that's 960. Let me check my calculator here. So 24 times 40. Yep, 960. So 960 minus 24h equals 35h. If I add 24h to both sides, that'll cancel there. 960 equals, this would be 59h. And if you divide both sides by 59, you should get your answer. So h is going to be that. So let's see if we can reduce that. Let's think about that for a moment. Is it possible to reduce 960 and 59? So does 3 go into 59? No, because the sum of the digits is 14 and 3 doesn't go into 14. The more I think about this, 59 is a prime number, so only could be reduced if 59 went into 960. If I try that in the calculator, 960 divided by 59, I end up getting a decimal number. So this one that would be a legitimate answer. I think better answers, though, would be something where it tells you as a mixed number what that is. So let's see, if we take out our calculator, how many whole times does 960 get divided by 59? How many whole times does 59 go into 960? In other words, it's 16. And then what's 16 times 59? That is 944. So you can take 16 whole 59s, 15 or 16 groups of 59 out of 960. You'd be left with 16, because 16 plus 944 gets you back to 960. So this would be 16 and 16 over 59. 16 times 59 is 944, plus 16 more gets you back to 960. If you were to write this as an approximate decimal, let's say we rounded it to 2 spots, that would be about 16.27. So that's it for that one. And then number 18. Number 18 dealing with dilations. Number 18 looks like this. Identify the dilation, find its scale factor, and find the value of the variable. So being consistent with the way the book had things, they were going from blue to red. So this is getting smaller, therefore it's a reduction. So that's identifying the dilation. It's a reduction rather than an enlargement. So reduction, it's getting smaller from blue to red. The scale factor, you just compare similar sides here. So I'm going to compare these two. These two are matching up. So we have a reduction. That's one thing we need to know. We have 42, or I'm sorry, 24 to 42. So finding its scale factor. So remember with that, we put the pre-image parts, the first part goes on the bottom. The image part, where you're mapping it to, that goes on the top. So this becomes 24 over 42, which is the same thing as, you can reduce that. You can divide by 6, it looks like. You have 4 over 7, not 6. So 6 goes into 24 4 whole times, goes into 42 7 whole times. So it's a reduction. The scale factor is 4/7. The value of the variable, use this scale factor now and set up a proportion. So 4/7, a proportion. This would be 10 and b. So the 4 matches up with the smaller part, the 10, and then the b matches up with the larger part, the 7, the blue triangle part. So we just need to cross multiply that and solve for b. So we have 4b equals 70. You can divide by 4 here and here, and this will cancel out there. You're going to have 70 over 4. You can reduce that. You can divide both parts by 2, and you're going to have 35 over 2 if you do that. Probably not going to tell somebody that the length of b is 35 halves. You're probably going to say 17 goes into 2 goes into there, 17 whole times with 1 left over, so 17 and a half or 17.5. These are all acceptable answers, but I think the last two are the better answers. And that'll do it for the Chapter 12 review. Go back and rewind and refresh your memory on ones as needed. Make sure you are ready for the Chapter 12, not Chapter 12, I'm thinking of the wrong class, sorry, the Chapter 8 test coming up very soon. Be ready for that, very important grade. Make sure you got this stuff down.